All right, hey guys, this is lesson 18, more problems on area and circumference. We did both area and circumference yesterday, and we're just going to add a little bit onto that today. So our opening exercise says draw a circle with a diameter of 12 centimeters and a square with the side lengths of 12 centimeters on grid paper. Determine the area of the square and the circle. All right, so I'm going to switch over here to this grid paper. I know that the square will be the easiest to draw, so I'm going to start there. It says the side lengths of the square has to be 12. So if each one of these is 1 centimeter, I'm going to draw across here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can just go across here. This would be best if I was using a ruler. So that's 12 centimeters by 12 centimeters. Okay, so there's that, and then I need to draw a circle with a diameter, and diameter would be all the way across the circle. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there's the center, so this would be my radius of the circle, and if the diameter is 12, the radius is 6, and then I drew my circle there so I could see that it is 12 across for the diameter and 6 for the radius. If I look back at my question, so that was the first part to draw. The second part was determine the area of the square and the circle. So, oh, there's Capone. He's angry about something. Okay, sorry about that. Determine the area of the square and the circle. Well, I could go and count every single square that's inside this big square, but that's going to take a long time. So I'm going to use the formulas that I know. The area for a square, our formula would be length times width, which would be, I know each side is 12, so 12 times 12, and that's going to be 144 centimeters squared. And now he's drinking water, so it's really loud. Sorry about that. Okay, and then area of a circle is, if you can remember from yesterday, it is pi r squared. Pi r squared. And the r obviously stands for radius. So pi is 3.14 times, and our radius, we know that the diameter was 12, so our radius is 6, and I have to square that. 6 squared is 6 times 6, which is 36 times pi, or 3.14. And let me grab the calculator. 3.14 times 36 equals 113.04. 113.04, or 4 hundredths centimeters squared. Okay. We have to brainstorm some methods for finding half the area of the square and half the area of the circle. Well, I could, if I had this on paper, I could just cut it in half, fold it in half, and then count all the squares that were on that half. Same thing here with the circle. But I think it would be easier to, if I know it's half of something, I know I just have to cut that in 2 or divide by 2. So on this one, I would just say divide my area by 2. Or I can times the area by 1/2, which is the same thing as dividing by 2. So either one of those would really work. It says find the area of half the square and half the circle. Well, the area of the square was 144. So if I use this divide by 2 method and I divide that by 2, I would get, what, 14 divided by 2 is 7, 4 divided by 2 is 2, so 72 centimeters squared for the square. So our square is 72 centimeters squared, and our circle, our area was 113.04. This one I'm going to use a calculator for. It doesn't come out so easily. Divide by 2, which is 56.52. 56.52 centimeters squared. And I got that by dividing those full areas by 2, because that would give me half. What is the ratio of the new area to the original area for the square and for the circle? Okay, and I know that it needs a ratio, which we can write as a fraction, and the new area to the original area. So new area will be on top, original area on bottom. New area for the square was 72. Original was 144. And that reduces to 1/2. So our ratio for the new square is 1/2. And for the circle, it was 56.52 is the new, which is half of the circle, and the original, the whole area of the circle, was 0.4, which also reduces to 1/2. So our ratios are the same, 1/2. Write an algebraic expression that expresses the area of the semicircle and the area of a quarter circle. Okay, so algebraic expression just means using letters and numbers, and an expression would be like our formula. We want the area of a semicircle, so I'm going to write semi, which semi just means half a circle. So don't get caught up on the word semi. And then quarter, area of the quarter of a circle, which is just, we had a full circle, it would just be 1/4 of it, 1/4. Because a quarter is 1/4 of a dollar. Kind of think of it that way. So how do we find the area of half a circle? Well, what did we do? We found the area, which was pi radius squared, and we divided that by 2. So I could write divide by 2, or remember, we talked about how we could either divide by 2 or times by half, because it's the same thing. So instead, to make this look a little simpler, I'm going to do 1/2 times pi times radius squared to find a semicircle, because semi is half of the circle. So if we follow that logic for a quarter of the circle, anybody know what fraction goes with a quarter? Okay, well, a quarter is 1/4 of the circle, so I'm going to do 1/4 times pi radius squared, and that would give us the quarter of a circle. All right, on to example 1. Find the area of the following semicircle. Remember, we're going to use that formula, half times pi times radius squared. And in this case, it says use 22 over 7, the fraction form for pi, because we can write pi as pi. If we want it to be the exact, we can write it in fraction form, 22 over 7, or 3.14. All of these are ways to write pi. So I know here it looks like our diameter is 14 centimeters. That doesn't help me in this formula because I need the radius. So if the diameter is 14, the radius is half of that, which is 7. So I'm going to rewrite this 1/2 times pi times 7 squared. And then I'm going to start filling in. I know 7 squared is 7 times 7, which is 49. Times, and I can write this all in fraction form, so 49 is the same thing as 49 over 1, times, they want us to use 22 over 7 times 1/2. So I'm just going to do my first two fractions, 1/2 times 22 over 7, which would be 22, because 1 times 22 is 22, and 2 times 7 is 14. And then I'm going to take that new fraction times 49 over 1, and let me grab my calculator. 22 times 49 is 1078. All over 14 times 1 is 14. And then I can divide those. So 1078 divided by 14 equals 77. So 77, oops, let me write it up here so I have more space. 77 centimeters squared is the area of that semicircle, the half circle. And I could times this number by 2 if I wanted to get the area of the full circle if we added another half to that. I also want to point out that there's another way that you can solve this problem or start to solve it to make it easier than doing 22 times 49. I can try to cross cancel some things out if I can reduce. So I'm going to switch over here to red. I know that there's a number that goes into 14 and 49, and that number is 7. So I could divide this side by 7, and this would be 2. And I can divide this by 7, and it would be 7. And then 22 times 7 is a little bit easier than doing 22 times 49. So then I could just multiply across and get 22 times 7, and then do 2 times 1, then just divide by 2, and I'll still end up with this 77 when I'm done. Okay, let's look at what is the area of the quarter circle. Remember our formula for a quarter of a circle is we're going to use our fraction 1/4 times, and again, we're going to use this 22 over 7 times our radius squared. This is our pi times radius squared. That would give us our area. Times by 1/4 would just give us this 1/4 of the circle instead of the whole circle. So our radius in this case was 6 centimeters. 6 squared is 36. And I'll write that as a fraction, 36 over 1 times 22 over 7 times 1/4. All right, and start multiplying across here, starting with 1/4 times 22 over 7. 1 times 22 is 22. And 4 times 7 is 28. Then I have to times that by 36 over 1. And this might be where I try to reduce. I know 22 and 1 I cannot reduce, but 28 and 36 what could go into both 28 and 36? All right, so 28, I have 1 and 28. I know 2 times 14 is 28, and not 3, 4 times 7. And I think that would be it for 28, 36, 1, 36. 2. And what's 36 divided by 2? I know it goes in there evenly. 36 divided by 2 is 18. There we go. 18, 3, and 12. What else? 4 and 9, 5, and then 6 and 6. So it looks like our greatest common factor is probably 4. So we've got a 6. Yep, so 4. So if I divide both sides by 4, what is 28 divided by 4? That's 7. And 36 divided by 4 is 9. Okay, now I can multiply across and it's a little bit easier. 22 times 9. 22 times 9 is 198. And 1 times 7 is 7. And then I just have to do 198 divided by 7. Okay. When I divided that out, I got this 28.28571442. Okay, so 28.285742, on and on. So if it's a decimal like this and it just keeps going, another way that you can write it is just written in form like this, if I know that it's a really long decimal. So I could just say the area is approximately, and instead of saying equal to, if you use curved equal signs, and that means approximately, which means about 198 over 7 centimeters squared. Okay, example 2 says Marjorie is designing a new set of placemats for her dining room table. She sketched a drawing of the placement on graph paper. The diagram represents the area of the placemats consisting of a rectangle and 2 semicircles at either end. Each square on the grid measures 4 inches in length. So this is 4. This is 4. This is 4. Find the area of the entire placemat. Explain your thinking regarding the solution to the problem. Okay, so I know that each one of these is 4, and I have 4, 8, 12. So it's 12 here. If these are both 4, then across this is 8. And like I said, this is 12. So we're wanting to find the area. The first thing I would do is find the area of this rectangular piece. And then I'll find the area of these 2 circles, these 2 half circles, and add them together. And that would be the area of the whole thing. So if I know that this is 8, the rectangular piece is 8 by 12, I'd have to do 12 times 8, my length times my width. 2 times 8 is 16. 8 times 1 is 8, plus 1 is 9. Okay, so my rectangular piece is 96 centimeters? No, inches squared. Now I have to find each of the semicircles. And in order to find the area of the circle, I have to do pi radius squared. Okay, my diameter is 8. So the radius is half of that, which would be 4. Radius squared times pi. So 4 squared is 16 times pi. And there's 2 of those, right? I have 16 pi and another 16 pi inches squared. Okay. So I'm going to use 3.14 for pi. I'm going to do 16 times 3.14. That gets me 50.24. That would be the area of a whole circle. So I would have to divide that by 2 to get me 25.12. I have to divide each of these by 2 to figure out the half circle. And I said, what was that, 25.12? Yes. So 25.12 or 12 hundredths, 25.12, which is 12 hundredths. The interesting thing here is if I know that they're 2 half circles and they make a full circle and then they have the same radius, I wouldn't even necessarily need to divide this by 2. I could just take 16 times pi and that would give me a whole circle. But it's easier for some people to split this up and think, okay, half circle, and rectangle, 3 pieces. So I have 96 plus 25.12 plus 25.12. And 25.12 plus 96, which gives me 146.24. 146.24. 146 and 24 hundredths inches squared would be the area of one of those placemats. Okay. Now it says if Marjorie wants to make 6 placemats, how many square inches of fabric will she need? Assume there is no waste. So we want to know our exact amount here. We know that one placemat is 146 and 24 hundredths inches squared. And if she wants 6 of those, I'm going to times that by 6 to figure out how much she's going to need total. So times by 6, 877.44. 877 and 44 hundredths inches squared is going to be how much she will exactly need for those 6 placemats. Marjorie decides that she wants to sew on a contrasting band of material around the edge of the placemats. How much band material will Marjorie need? Well, if we have that placemat, and I'm just going to kind of draw a loose example of it again. Here we are. She wants a band of fabric to go around the edge, around this edge here. Well, that isn't the area anymore. What is around the edge of that called? That's going to be our perimeter. Okay, and the perimeter for a circle, we can either use 2 pi r, or 2 times the radius is our diameter, so pi times the diameter. And then of course for our flat pieces, this is part of our rectangle. Well, we already knew that this piece was 12, and so this is 12. For our circle, we know that this is 8. I need to figure out this. So in order to figure out the outside edge of the circle, I'm going to have to find my circumference or perimeter of the circle. Circumference. And if you can remember back, that's one of these two formulas. Pi times the diameter or 2 pi r. If I add this and tack this piece on, it's going to be a full circle. So I can find the full circumference of this circle. Since I know the diameter already, I'm going to use this pi times the diameter formula. So pi is 3.14 times 8. So 3.14 times 8 is 25.12. Okay, and then I have to add 12 for this side and 12 for that side. All right, and if I add all of those, whoops, 0, 0, 0, 0. Okay, so that's 2, 1, 5, 2, and 2 more makes 9, and 2 plus 1 plus 1 is 4. So our total perimeter would be 49 and 12/100 inches of fabric to go around the outside band of those placemats. All right, example 3. The circumference of a circle is 24 pi centimeters. So they're saying that all the way around is 24 pi centimeters. What is the exact area of the circle? Draw a diagram to assist you in solving the problem. Okay, so I've already started to draw. Here's my circle. Here's the diameter. This would be my center point to help me with the radius. What information is needed to solve the problem? Well, I know the circumference, but I'm trying to find the area. And remember, area of a circle, our formula is pi, r squared, pi radius squared. Well, I have to figure out the radius to help me. So what can I do to figure this out? If I know that the circumference is 24 pi, and our formulas for circumference are diameter times pi or 2 pi r. Well, I see this pi symbol already right there. So I can tell that this 24 has to be my diameter because it's already written in this form. So 24 is my diameter. So my radius, if this whole thing is 24, half the radius is 12. So this information right here, what is the information you need to know? Well, you have to know the diameter. We already figured that out as 24. We have to know the radius, which is 12. And we have to know this formula, pi r squared. And then to figure it out, we could just simply put in our numbers. All right, so we've got pi times radius squared. Our radius we found out was 12 squared. So this would be 12 squared is 144. And when it says find the exact area, we're going to leave it in terms of pi. So I'm not going to write 144 and then times that by 3.14. I'm just going to write 144 pi. Because if you remember, and centimeters squared. If you remember this pi, if we use 3.14, that's not actually pi. Pi is a really long number. That's approximately 3.114, but it continues on. So in order for us to get the exact area, we have to leave that pi symbol on there. Okay? All right, we're going to do one more of these, and then we'll save some to do tomorrow in class. Here's the first exercise. Find the area. Okay, I'm going to start by writing in my formula. Area is of a circle is pi radius squared with a diameter. I know the diameter is 42 centimeters using this 22/7, this fraction form of pi. Okay, well, my formula calls for radius, not diameter. So in order to find the diameter, I have to, or the radius, sorry, divide by 2, which is 21 centimeters. And then I can plug this in here. So I have pi times 21 squared, and 21 times 21 is 441. 441. And then I have to times that by pi, which in this case they told us to use 22/4. So 441 all over 1. That would be fraction form times 22/7. So let's do 441 times 22, which is 9,702. All over 1 times 7 is 7. And then I can divide 9,702 divided by 7. And it comes out evenly, so we won't need to leave it. 1,386 equals 1,386. If it did not come out evenly and had a really long decimal, we would leave it in this form. But since it didn't, this will be perfect. 1,386 centimeters squared is our approximate area for this circle. Okay, so we'll work on the others later in class tomorrow.